A very good morning to everyone. Today we are here to do a presentation. Our presentation topic is integration. Before that, let me introduce my group members. Firstly, it is me, Tarvin Raja Nalaki Chandrasekharan. My matrix number is 01 DKM2F1013. Second is Muhammad Afiq bin Usman. His matrix number is 01 DKM22F1017. Third is Muhammad Afizul bin Nur Isham, 01 DKM22F1027. And lastly, Muhammad Daniel Aikal bin Isa, 01 DKM22F10111. So next, I will be revealing the team roles and responsibility of our group members. Okay, firstly, Tarbin, it's me. I will be explaining the introduction for this presentation. Secondly, Afiq will be explaining the introduction of application in real life. Thirdly, Afizul will be explaining the question and solution. And lastly, Daniel will be explaining the summary for this presentation. Okay, now I am going to explain the introduction of this presentation, integration. Integration is a method of adding or summing up the parts to find the whole. It is a reverse process of differentiation where we reduce the function into parts. This method is used to find the summation under a vast scale. Integration also can be used to find areas, volumes, central points, and many useful things. But it is easiest to start with finding the area between a function and the x-axis like this. You all can see the graph below this introduction. So next, I will be passing up to Afiq so that he can explain example of application of integration in real life. Thank you.
Okay, now I will explain about the example of application of integration in real life. So the question is during a car race, a car's acceleration is 20 square meter per square as meter per s square. Find the distance traveled by the car after 4 seconds if second equal 30 meter initially and the car velocity after 2.0 second is 20 meter per second. So for the A equal 20 square meter per second square. So next, I'm going to tell about the solution from the question. Integrate with respect integrate VDT to time. V equal integrate ADT, and then we change the A become 10t square and integrate. You can get the answer 3.33t power of 3 plus C1. When t equal 2.0 second and v equal 20 meter per second, then 20 equal 3.33 bracket 2.0 power of 3 plus C1. C1 we can get this answer. C1 is a negative 6.64 and v equal 3.33 t power of 3 minus 6.64. Distance per second equal integrate velocity v. And then s equal integrate v dt, s equal integrate bracket 3.33 t power of 3 minus 6.64 bracket dt. After that, integrate 3.33 t power of 3 negative 6.64 t become the answer is 0.8325 t power of 4 minus 6.64 t plus C2. So when s equal 30 meter 30 m, t equal 0s, and then 13 equals 0.8325 bracket 0 power of 4 minus 6.64 bracket 0 plus C2, and then we can get answer C2 equal 13. Hence s equals 0.8325 t power of 4 minus 6.64 t plus 3, 13. S equals 0.8325 t power of 4 minus 6.64 t plus 13. To find the s when t equal 4s, s equals 0.8325 t power of 4 minus 6.640 plus 13, and s after that s equals 0.8325 bracket 4 power of 4 minus 6.64 bracket 4 plus 13, and the answer s is 199.56 m. Therefore, the distance traveled by the car after 4 is 199.56 m.
Okay, now we go to question and solution. The question is, given the graph of curve with equation y equal s power of 2 plus 2s minus 2 and the straight line y equal s plus 4. Determine the coordinate of intersection point A and B. The area bound by a line y equal s plus 4 and a curve y equal s power of 2 plus 2 minus 2. Now, this is the graph. Okay, now the solution of A. The coordinate of intersection point A and B. Y equal s power of 2 plus 2s minus 2. Y equal s plus 4. S plus 4 equal s power of 2 plus 2s minus 2. And then 0 equal s power of 2 plus 2s minus 2 minus s minus 4. And then 0 equal s power of 2 plus 2s minus s minus 2 minus 4. And then 0 equal s power of 2 plus s minus 6. S1 equal to S2 equal negative 3. A equal negative 3. B equal 2. The coordinate of the intersection from A is negative 3, while B is 2. Okay, now I will pass to Hafizul.
Okay, next I will explain about solution for question B. The area bounded by the line y equal to x plus 4 and cross y equal to x power of 2 plus 2x minus 2. Y1 equal to x plus 4 and y2 equal to x power of 2 plus 2x minus 2. Integrate to negative 3 bracket y1 minus y2 bracket dx. Integrate to minus 3x plus 4 negative bracket x power of 2 plus 2x minus 2 bracket dx. Integrate 2 minus 3 bracket x plus 4 negative x power of 2 negative 2x plus 2 bracket dx. And integrate, we can get integrate 2 negative 3 bracket negative x power of 2 plus x negative 2x plus 4 plus 2 bracket dx. And we can get integrate 2 negative 3 bracket negative x power of 2 plus x plus 6 bracket dx. And we can integrate, and we can get bracket negative x power of 3 per 3 minus x power of 2 per 2 plus 6x bracket and 2 negative 3. And we can enter the 2 and negative 3 in the question, and we can get bracket negative bracket 2 power of 3 per 3 minus bracket 2 power of 2 per 2 plus 6 bracket 2
and minus negative bracket negative 3 power of 3 per 3 negative 3 power of 2 plus 2 and plus 6 and bracket negative 3, and we can get 20.83 unit. Okay, thank you. I will pass to Danny Haika for explain about the summary. Okay, thank you.
Okay, now I will tell about summary. The conclusion of national integration is that it provides equal opportunity for all citizens of the country. It is critical for any government that has social, cultural, religious, linguistic, and geographic diversity. In math, integration is a method of adding or summing up the part to find the whole. It is a reverse process of differentiation, where we reduce function into parts. This method is used to find the summation under the vast scale. Okay, that's all for us.
Okay, thank you.
Thank you.
Thank you. Tutup. Okay.